TFTP stands for Trivial File Transfer Protocol. Then emails, these are text. You can email text, you can email sound, you can email images, you can also email the videos. Then web surfing, searching, this could be multimedia or real time. Then computer-aided design and computer-aided engineering, as well as medical, these are still images, the still images. Internet telephone, it's a real-time audio. Internet telephone, real-time audio, where you can call using the internet. Skype is one of the example. Even Zoom is one of the example of this internet telephone. Then you can stream radio, you can stream radio, TV, voice over data. This is real-time audio or real-time video. You can stream a video or you can stream just an audio. Electronic data interchange, it's also multimedia or data or simply text. E-learning in education, it could be multimedia, it could be data, but or text. When you look at the advantages of, multimedia consumes a lot of data. Text, it doesn't consume a lot of data. So I can advise you, even when we are doing Zoom, try by all means to turn off video. Just the way, as you can see myself, you can't see me, but I've just kept the audio. I've switched off the camera, because video will consume a lot of bandwidth. So you are going to be experiencing maybe the internet will be fluctuating, or maybe I'll start breaking. So just make sure that we are on the voice only. Types of traffic. We have data / files. Actually, these it can be binary, it can be text. We all know that computer only understands zeros and ones. It understands binaries, but the text is coming in because text, it's what we read. It's a human readable form. Otherwise, we are reading like this. What we see on the screen, we can see the text. But what the computer is seeing behind, it is just zeros and ones. We call it a computer language. Zeros and ones. So these can be documents, of course, emails, databases, queries, web pages. So you see those as in text, but those behind what the computer will see, it will just see zeros and ones, binary digits. Then types of traffic, we can be dealing with audio sometimes. So audio, it's a type of traffic that is found on the network. It could be data or files, or audio, analog, digital, or varying quality. Then we have still images. It's also a type of traffic, still images. We have also motion videos. We have still images, then we have motion videos, analog, digital, varying quality, sound, pictures, and synchronization. So audio and video may be compressed. Not may be compressed. Most of the time, audio is compressed or video is compressed. If you don't compress it, the file becomes too large. Sometimes even uploading, if you exceed a certain number, like let's say you're uploading the coursework, they will tell you that you shouldn't, the file shouldn't exceed 20 MB. Then you find that your file is about 50. So we have to compress it to make sure that it becomes 20 or below 20 MB. If it's too large, the internet can't take it anywhere. Then we have performance parameters and units of measurements. Performance parameters or unit measurements. Let's say performance parameters, we have response time. Response time can be measured in seconds, can be measured in milliseconds, can be measured in nanoseconds. That's U like S, it's a nanosecond. Even end-to-end transfer delay. What it means by end-to-end transfer delay, it's the time the packet will take from the source to the destination. How long does this packet take? So it could be in seconds, it could be in milliseconds, it could be in nanoseconds. Response time, I send you an email. How much will it take for that email to reach and also respond to it? Then we have delay variations. Actually, delay, we know delay, but delay variations is called jitter. Delay variation, it means that, let's say we have the packets. And these packets, just a minute. So delay variation means that when the packets are broken down, they are in segments, but they are using the same header. I'll explain more when we do OIS model in detail. When we do the OIS model in detail. When these packets are broken down, into segments, and these segments are going to the same destination. I can give you an example. Let's say we are going into town. You can use the Bama Road. Someone can use Chirimburu Road. Another one can use the different means of getting into town. You can start at the same time, but I can assure you that you are not going to arrive at the same time. So that difference is called jitter. That's variation is called jitter. Others will arrive 30 seconds before this one, another one 20 seconds, just like that. That's what we call jitter. Then we have throughput. We have throughput where bits, seconds, the performance throughput, then the parameter, we have bits per second. By the way, never ever say bytes per second, because a bit is smaller than a byte. When you are converting anything, you have to convert it into the bits, okay? It's 8 bits that will make a 1 byte. Are we together? 8 bits will make a byte. Then 1,000 bytes. 1,000 bytes will make a what? Actually, what? Yeah, we'll make a meg. Not the megabyte, but
a kilobyte.
A kilobyte, yes, and not actually 1,000. It's actually 1,024. They just when they just round off, that's when they arrive at the 1,000. So from KB, from kilobyte, then we have 1,000 kilobytes. It will make MB. Then from MB, we'll go to gigabyte, GB. From a GB, we'll go to a terabyte.
Gigabyte.
From GB, we'll go to megabyte, right? From megabyte, we'll go to a terabyte. From a terabyte, where do we go?
Petabyte.
The petabyte, then after petabyte, exabyte. Exabyte. Okay, so throughput. Who can define a throughput? What is a throughput? The word throughput. Define the word throughput.
Is it the time that is taken for a byte to reach the other side?
No.
Or that?
No. Okay, I'll ask it later. You have to know throughput. These are the terminologies you need to understand, even when you are doing the courseworks, because all these we can't perform a coursework without understanding. Okay, you can go ahead and ask a question. Hello?
Oh, I wanted to answer the question.
Oh, the throughput. Okay. Yeah. Go ahead.
So basically, this is just the amount of. It's just a measure of how much data can pass from one node to the next, or from the source to the destination.
Exactly. That's what a throughput is. That's what a throughput is. Okay. Then what does it mean by packet loss or error rate? It's normal when you send a packet. When you send the packets, it's normal that you can. I mean, it's normal that you can lose a packet when there's an error. When there's an error, if you lose a packet, meaning that that packet has been dropped. So at the transport layer, if this type of traffic is using the TCP, the transmission control protocol, if the packet is lost, one of the characteristics of the TCP is to resend that particular packet, because TCP uses a three-way handshake. It uses a three-way handshake. If the packet is lost along the way, it has to be resent, different from a UDP. So packet loss, error rate of fraction or a percentage. Then we have bit error rate, which is short for BER, bit error rate. The rate at which the bit cause an error. We'll talk about what will cause the error, how the error occurs, how do we avoid the errors. Yeah, when you are doing the courseworks, you need to explain nicely. Then we have core blocking rate, fraction percentage, network access delay. Then we have transit delay, network access delay, the transit delay. Transit delay is when already the packet is on a transit going to its destination. A lot of things happen there. You expect the network to fluctuate and the packet not to arrive at the intended time. Then if there is too much delay, that packet won't reach the destination. Unfortunately, it will be dropped. It will be dropped. How does the loss and the delay occur? Packet queue in a router, buffers before being forwarded. When we look at quality of service, some of you've learned about the quality of service. We've got different techniques. What you see there, where those arrows are pointing, it's a memory. It's like a memory. What you see on the right-hand side, it's actually a router. We call it a router, a processor. Okay, so a router, we have the computers, computer A and computer B, they are both sending packets. So if these stations find that the memory is full, that is a buffer, by the way, if the memory is full, if this packet coming find that this memory is full, this packet need to be dropped. It will be resent later. Then, as you can see, the router or the processor is removing the packet one by one. They are being processed. So what you see there, it's a queue. So packets are in a queue. So this is what we call a delay. Then those white slots, meaning that they are available, it's not yet full, they are available. So free available buffers arriving packets dropped, lost if no free buffers. So if there are no free buffers, definitely the packet which will follow, it has to be dropped. Then we have a packet being transmitted. That packet, the green one, meaning that it's on a transit. It is being transmitted to the router. So packet arrival rate to link can exceed output link capacity. Packet arrival rate can exceed output link capacity, meaning that the sending station can be faster than a receiving station. So the receiving station, due to the packets that are waiting to be processed, it can be slower than someone who's sending. So in quality of service, we say, actually we say the window size. The window size, it's what you can actually receive at that particular time. That is the window size. I can give you the real life example. Let's say if you can eat 2 lamps, that's your window size. If you are given 3 lamps, meaning that it's a waste of the resources, because you are not going to finish the 3rd lamp. So the window size is 2. How do we establish the window size? The window size we can establish like a TCP. If you're using a TCP, the sender and the receiver, they establish connection, or they establish the connectivity. So during that establishment, the sender will even ask the receiver, how many packets can you receive at a time? So the receiver will say, I can receive, let's say, not packets, by the way. Packets are broken down into segments. I can receive 5 segments. I can receive 5 segments. So meaning that the sender will be sending 5 segments at a go. Then in TCP, the sender is not supposed, the station is not supposed to send another 5 segments without receiving the acknowledgement, right? Without receiving the acknowledgement. When the acknowledgement is received, the sender will know that the first consignments arrived. Okay, we'll get into detail later. We'll get into detail later, especially when we are doing the advanced networks. Then 4 sources on packet delay. There are 4 sources that makes a packet to be delayed. There is a processing at a text node or TX node, can be a computer, or it can be a router. It can be a computer, can be a router, sometimes even a switch. So under processing, we have operating system scheduling, check for bit errors, then you determine output link, Then we have also the queuing. A queuing is time waiting at output link. Anyway, you know a queue, just a normal queue. Even on the network, there's a queue. Those packets can be queued. That's why we have the traffic on the network. We'll talk about how we can avoid traffic, avoiding network congestion. So time waiting at output link for transmission depends on the congestion level of the router. But we all try by all means to avoid congestion. So we call it congestion control. How do we control the congestion or congestion avoidance? So we have computer A and B. Between computer A and B to that packet, the green packet, is called transmission. So meaning that from the host to the buffer, we say transmission. So there is transmission delay. There are types of delays. Think of transmission delay. Transmission delay is when the computer sends a packet to a buffer, or a memory. So in that memory, those packets in that particular memory, they are waiting to be propagated. They are waiting to be sent to the router. Okay, that's called a transmission delay. Okay, it's like you go to a certain offices before you are being attended to. You are waiting. It will be more like in transit, transmission delay. Then we have when the transmission now already starts heading to the router. That's called a propagation. There's also a propagation delay, meaning that in that pipe, there's also a delay for the packet to arrive at the router. It's called a propagation delay. Then we have node processing. Then queuing, it's the packets which are already in that particular memory. It's called, so we have queuing delay, transmission delay, propagation delay. Transmission delay now, ARA link bandwidth, meaning that ARA, it could be the host. ARA link bandwidth, BPS stands for bytes per second. Then L is equal to packet length, bits. How big is that particular packet? Then time to send bits into link LR. So I talked about transmission delay. I talked about a propagation delay. So D is equal to length. This is distance equal to length of physical link. What is the length of a physical link? In a local area network, like if you're using Cat5e or Cat6, the length is supposed to be, you know, a Cat5 cable or 100 base T, it means that this link is not supposed to exceed the 100 megabytes per second, or 100 megabyte, or 100 meters, which means 100 megabytes per second. Then we have second, propagation speed in medium. So if you say 2 by 10 to the power 8, then you get that answer, a minute per second. Then we have got propagation delay, distance over seconds. So note that S and R are very different quantities. TX delay is sensitive to technology, propagation delay sensitive to distance. Propagation delay sensitive to distance. In terms of propagation, you delay according to the distance in that particular pipe now, in the pipe. Then TX delay is sensitive to technology. It depends on the type of technology that you are using. Some vendors are good. Let's say we are so familiar with Cisco routers, Cisco switches. We are not yet familiar with Huawei routers and switches. We are still learning. So if I may ask a question, a lot of people say I'm conversant with Cisco technologies, isn't it? Because they might be better. Then in terms of LAN, we talk of Ethernet technology. By the way, we are using, this is a free version of Zoom. So after 10 minutes, you time out. Just make sure you log in within seconds. I'll be already online. Hello? Okay. Delays on the internet, these are just statistics, which we are going to collect types of these results using the Riverbed, using the OpNet when we install OpNet. And for OpNet, we'll continue having classes just like the way we are having. But I said on Saturday, we can find time, we meet in school where I need to install Riverbed or OpNet for those who doesn't have on their machines. So notice the delay variation on which graph is it higher. Like this, looking at the graph, the delay is higher on the second graph. As you can see, there were a lot of, the delay was too much. It started on 524, it dropped. It was fluctuating, but it was higher. When you look at the first graph, the delay was almost constant on 140. Then at some point, when it reached, like these times they are showing, when we talk about the internet, we have off-peak and peak hours. Peak hours, you find that the internet is very, very slow because almost everyone is on the internet. Then off-peak, like around this time, this is off-peak actually. Most of the time are not online. So internet will become a bit faster than during the day, isn't it? Are we together?
Yes, we are.
Okay. So we'll produce such graphs in when we start designing a network in OpNet. This is shows a global packet loss in 30 days. These statistics can be conducted by maybe the ISPs. They want to find out if at all they are the loss or not in 30 days. So they can measure like this. There are so many statistical tools that can be used. Bandwidth bit rate. First, some number representation and units. We have power of 10. You know what it means by, when we say, before we look at this 1000, a kilobyte, 10 to the power 3 gives you what? It gives you what? Let's try to calculate that. 10 to the power 3, it's what?
10 times 10 times 10.
I'm sure you've got scientific calculators. You do, isn't it?
1,000.
Are you sure it's 1000 exactly? Eh?
Yes, it's 1000.
1,000.
There's no 24.
Why 24?
Because a kilobyte is not exactly 1000. It's 1024. It will make a kilobyte. They just say 1000 because they round they round it off. So you don't have calculators, isn't it? Huh?
Just a minute. Are we saying 10 to the power 3 or 2 to the power 10?
The 10 to the power 3. Okay.
It is 2 to the power 10.
Yeah, I suppose. Oh, supposed to be 2 to the power 10. Yeah, you're right. 2 to the power 10. Yeah, because it's powers
So
of 2.
2 to the power 10 is 1024.
Yeah, you are right. Okay, yeah, you are right. 1024. Then what about 2 to the power 10? 1024.
Yes. So you
All
see
right.
there 10 to the power 3 is 1000.
Oh, okay, yeah. So that's how we use the powers of 2. That's how we use the powers of 2. So kilo, it's in milliseconds. Mega, it's in microseconds. Gigabyte, it's in nanoseconds. Then terabyte, it's a picosecond. So a terabyte, it will be faster. It will be faster than a gigabyte. So we have 10. We have, when we say 10 minus 12, 10 minus 9, 10 minus 6, then 10 minus 3, meaning that 1000 we divide by 1, we divide by 1000. So those are the powers of 10. Then we've got the fractions. We have the analog, which are measured in Hays. Which one is measured in Hays? It's a clock rate of a computer measured in Hays. Hays is speed. Let's say speed is measured in Hays. Then we have digital bits per second. So in the computer world, we reckon in powers of 2. Yeah, powers of 2. So 2 to the power 10, 2 to the power 10, 2 to the power 20, 2 to the power, just like that. Okay. So typical requirements of bandwidth. Analog telephone, the speed is 3 to 20 kilohertz. Analog telephone, these are normal phones that Zamtel will connect you. The speed is 3 to 20 kilohertz. Then we have digital voices, or digital voice, which is 64 kilobytes per second to 1.5 megabytes per second. This one is uncompressed. Then we have a text, 10 kilobyte bits per page. It's 28 kilobytes per second to 0.35 seconds per page. This is the text, how long it will take to open a page on the internet. Then we have the image. The image is 1 megabyte, which is 1.544 megabytes per second. to digital signal. Digital signal 1, DSI, I think stands for digital subscriber, digital subscriber. Then we have motion video, which is 25 megabytes per second to 2 Gbps, gigabytes per second. Compression is essential because it's too large, you have to compress. Video, you have to compress. If you are sending a video over the internet, some things they can't even go if it's too large. I'll give you the example of WhatsApp. A certain site, it will reach a certain site that can't even be transmitted over the internet. Even the email, it's just that when you look at the Gmail, at least it's a bit advanced because we have a Google Drive. Some certain things will go in a Google Drive. Quality of service requirements, voice. When we are dealing with a voice, we have to put more effort because the voice will need more requirement. So the delay in voice, the normal one is about 250 milliseconds. The jitter can be 10. I explained about the jitter. A jitter is a variation of delay. Then loss, it can also about 10%. It's normal to lose some. Then bandwidth, megabyte per second, is about 0.064. That's how it's consumed. Then we have video, which is also about 250 milliseconds. Jitter is 10, loss is about 0.1 loss. Then bandwidth is about 100. Compression video is also 250, jitter is 1. We have also loss there. 10 minus a 7, then we'll get the difference. Then bandwidth is 10 minus 2 minus 10, which will give us 8. Then we have image, the delay is 1 second. The image, especially if they are compressed, they are faster to arrive at the destination. Jitter, there's no jitter. Loss, same as a compressed video. Even bandwidth, same as the compressed video. Then a data file. Let's say you are sending a file.